Let's take a challenging problem on coordinate geometry, and the question says that consider a fixed point A 5 comma 2 and also B and C are two distinct variable points moving on x minus y equal to 0 and y equal to 0, that is x-axis respectively. So B is moving on this particular line and C is moving on this particular line. A is a fixed point. Now we need to find the points B and C such that AB plus BC plus CA, the sum of the distance, is minimum. So AB plus BC plus C has to be minimized. Now for this question we'll be following a very important idea, that is, you can see out there, the idea that I've given to you is that follow the path of light and you will be enlightened. Follow the path of light and you will be enlightened. So the idea is that we need to use the concept of Fermat's principle, which says that light ray travel along the least path. So we need to make sure that from the particular point A, if I start a light ray, or a light ray starts from the point A, then after reflection from the point B on y equal to x, it will be again be getting reflected from the point C on the y-axis, and ultimately it should come back to A. So if you can arrange this kind of situation, then since the light ray will be traveling along the path AB, then BC and CA to come back to A, and then the sum of the distance is definitely going to be minimum. So to achieve this, we can see that I have considered the point A to be 5 comma 2, and naturally A1 will become the image of the point A about y equal to x, which is the mirror. So clearly we can write down the point A1 to be having a coordinate 2 comma 5, right? Because as you know that if a point has a coordinate A comma B, then the reflection about y equal to x will become B comma A. The coordinates just get swapped with each other. And we can also say that 5 comma 2 will have an image A2 about the x-axis, which is definitely going to be 5 comma minus 2, which is the image about the x-axis. So we can see that A1 is the image about y equal to x, and A2 is the image of the point A about x-axis. So basically the light ray will be traveling from A to B and then reflecting back, creating an image of A at A1, and then further BC will be reflected to create the reflected ray CA, and in the process A1 will have or the point A will be having the further image at A2. So we can write down the equation of A1 A2. As you know that A1 and A2 will be collinear with B and C. So equation of A1 A2 can be obtained using the 2-point form. So A1 A2 is the line joining the point 2 comma 5 and 5 comma minus 2. So we can quickly write down the equation of the line A1 A2 to be y minus 5 divided by x minus 2 equal to 5 plus 2 divided by 2 minus 5. So the equation on simplification will come out to be 7x plus 3y equal to 39. Okay, this is going to be, 29. So this is going to be the equation of the line A1 A2, and you can see that A1 A2 will be cutting y equal to x at this particular line, will be cutting the line y equal to x at the point B. So B is the point where the line A1 A2 is cutting the line y equal to x. So on solving this particular line A1 A2 with y equal to x, so simply substituting y by x, will be getting 7x plus 3x equal to 29. So clearly x will be 29 upon 10. So we have got the coordinate of B to be 29 upon 10 comma 29 upon 10. This is going to be the point B, And on solving the line a1 a2 with the x-axis, that is y equal to 0, so on solving with y equal to 0 we'll be getting 7x equal to 29, so x equal to 29 by 7, so the point C will come out to be 29 by 7 comma 0.